All right, for numbers 1 to 3, we're going to state the function types and the operation used to combine them. So number 1, it looks like a trig graph because of the wave. So I'm going to say one function is the trigonometric. And then the midline has been changed. And that midline is a parabola, so that function is quadratic. And the midline is added to a trig function, so the operation would be addition. So it would be something like cosine x plus the midline is x squared. So in number 2, again, I'm going to have another trig because of the wave, and then it looks like the amplitude's changing because I can see here's a small amplitude and it's increasing, and the pattern of the amplitude, if you connect some of the dots here, looks like it's a parabola, so I'm going to say quadratic again, but now the amplitude is multiplication as a coefficient on a trig, so that would be something like x squared cosine x, where the amplitude is multiplied by the cosine. Oh, and here's 3. I'm going to go with another trig function because of the wave. But now the amplitude's changing again, so I'm going to go back with multiplication. And if I look at the amplitude pattern, it looks like an exponential decay. So that would be an exponential function that's multiplied for the amplitude. All right, for number 4, Mr. Davis is playing baseball. We've got these parametric equations and a lot of questions about the ball. So I think I want to eliminate the parameter to get a rectangular equation that we're really used to using. So instead of 0.5, I'm going to make it a half. I'm going to isolate the t. So 2x equals t. And then substitute into the y function. Now you have to be careful. This negative coefficient is staying because it's not inside the squared. So then 2 squared is 4, x squared is x squared, and then that's going to be 40x. All right, so here's my rectangular equations. When will the ball hit the ground? Well, if you think about baseball, here's the path of the ball. And it's a reflected parabola, which is why we have a negative x squared function. So the x-intercept is when it hits the ground. So let's say 0 equals negative 4x squared plus 40x. I can factor out a negative 4x. And we would get x is 0 and x is 10. But that's not a when, that's a how far away. So that's going to be 10 feet. Yep, feet. So when does 10 feet happen? Well, if we plug that into the x, so when does 10 equal, like what time will this be? So if we multiply both sides by 2, the time is 20 seconds. The maximum height, so that's the vertex. So here we've got 0 and 10. The vertex is going to be halfway in between. So that's our distance. So that's 5 feet. Oh, sorry, you can't see down here. That's 5 feet. When that occurs, well, if this is t equals 20, that's halfway, so that's 10 seconds. And what is the maximum height? So we have a choice. You can either substitute 10 into the y equation, or you can substitute 5 into your rectangular equation and to get the maximum height. Let's just use the y. So that's negative 100 plus 200, which equals 100 feet. Just so you can double check it, let's plug 5 into, our rectangular equation and see what happens. Negative 4 times 5 squared plus 40 times 5, and we get the same answer. It's 100. So there's multiple methods for doing these problems. I like kind of to piece it together this way. You don't have to. You can just stick with the parametric and not eliminate the parameter. It's up to you. All right, number 5, Mrs. Strauss is playing golf. When will the ball hit the ground? So let me do this in the other method. That's when y is 0. When is a t, so that's a time. So 0 equals negative t squared plus 9t. I can factor out a negative t, and I get t is 0, which is where the ball starts, or t equals 9. So 9 seconds is when the ball will hit the ground. That's over here. At what distance? Well, if we take that 9 and plug it into the x, we would get the distance, and that's 27 feet. So here's 27 at t equals 9. What is the maximum height? Well, that's going to be halfway, or no, sorry, that's the y value halfway between 0 and 27, since parabolas are symmetrical. So that's at 27 over 2. At 9 over 2 seconds. You can do decimals if you like. So what is the maximum height? So the maximum here, let's plug in 9 over 2 to the y. The whole progress check you get your calculator for, so might as well use it. The parentheses are important with this negative and then the quantity squared. Or if you prefer a fraction answer, so either of these answers are correct. So we're going to say 20.25 feet. All right, more modeling. Given this function, sketch this one. So what transformations? This is down 3 and left 2. So this point here goes down 3. Wait, that's 1, 2, 3 to negative 6, and left 2 to negative 2. So there's our new vertex. Then I'll take this point, down 3 and left 2, and it's symmetrical because it's a parabola. We can do this one if I want to get another accurate point. So that was at 1. So down 3 and left, oops, sorry, it was here. Down 3 and left 2. There's our new graph. And last but not least in this section, oops, same parent graph. Now this is right 1 and up 2. So right 1 and up 2 puts me here. This graph, right 1 and up 2 puts me here. So then that would go, uh-oh, wait, something went wrong. Right 1 and up 2, right 1 and up, oh, that was too high. These are wrong. It's here and here. All right, careful with your counting. Don't mess up like me. This one, right 1 and up 2. Is that 3, 3? Right 1 and up 2. All right. And there's our answer.